Hey there and welcome back. This is the second part of our ReactJS for Beginners series. If you're brand new to React, I highly recommend checking out the first video before diving into this one. It covers all the fundamentals you'll need to get the most out of this session. Alright, if you're ready, let's jump right in. Alright, let's go ahead and navigate into our project directory. You can of course choose any location that works best for you. In my case, I'm going to create this project inside this dev folder. This command, as you may already know, is a vite command to scaffold a project with a JS framework. I'll give this project a name, select React from the options, and finally choose JavaScript. With the process completed, we can now open our project in VS Code. I will do that by navigating to the project directory and running the code command. This will launch the project directly in VS Code. Now that we've opened our project in VS Code, the next step is to install the project's dependencies. In the previous video, we used npm as our package manager of choice, but for this project, we're switching things up and using Yarn, a fast and reliable alternative to npm that many developers prefer for its speed and efficiency. Installing Yarn is pretty straightforward. In fact, you can use npm to install Yarn globally by running this command. To make things even easier, if you installed Node using the Node version manager, Yarn actually comes bundled with it. Since that is the case for me, I'll go ahead and simply enable it using this core pack command. To confirm that Yarn is enabled and working correctly, run this command to check its version. If everything's set up properly, you should see the installed version number. Now let's go ahead and install the project's dependencies by running the Yarn command. After installing the project's dependencies with Yarn, you'll notice that Yarn is set as the default package manager in the package.json file. Using a different package manager may trigger a warning. Now, let's go ahead and run the app. With the app running as expected, let's clean up the project by removing any unnecessary files and lines of code. The cleanup is done, and we now have a basic, bare-bones app. I've also prepared the assets we'll be using in the project, mainly images and fonts. For the images, I grabbed a few cloudy wallpapers from Unsplash. And for fonts, we'll be using Poppins and Cabinet. I'll include links to these resources in the description so you can download them if you'd like to follow along. Alright, let's get started by setting up our fonts for the project. We'll configure both Poppins and Cabinet so they're ready to use throughout the app. For that, we're going to use the font face rule to initialize each font. This involves specifying key attributes like the font family name, the source file and its format, and the font weight. We're including two URLs for this font. This acts as a fallback in case the browser doesn't support one of the formats. Generally, this format is widely supported across modern browsers, but having an alternative helps ensure better compatibility. Now, I'll go ahead and complete the remaining font face rules for each font, along with specifying all the necessary font weights. Keep in mind that some fonts have a variable weight, which means you don't have to specify each weight in the font face rule. You can simply adjust the weight as needed, since the font will support it dynamically. However, in my case, I didn't download the variable weight version of Pockins, so I'll need to explicitly define each weight in the font face rules. With the fonts configured, let's go ahead and import it at the top of our index CSS file. Now, let's go ahead and install Tailwind in our project. You can use this command, but remember, since we're using Yarn instead of npm, we'll need to adjust the command accordingly to install Tailwind with Yarn. Once the download is complete, we can double-check that Tailwind is present in our project by taking a quick look at the package.json file. But right now, it's not doing anything yet, so let's go ahead and configure the project to start using Tailwind. To get things working, we'll simply add the Tailwind Vite plugin to the Vite config file. That's all it takes for Tailwind to be recognized and processed in our project. There's one more thing I always seem to forget. We also need to import Tailwind into our index.css file. This is what actually pulls in Tailwind's base styles, components, and utilities into the project. With that done, you'll notice that Tailwind is already affecting the project. We're now all set to start using utility classes to style our elements however we like. Alright, with all the necessary configurations out of the way, let's dive in and start building our weather dashboard. Let's kick things off by defining some custom Tailwind utilities for the fonts we just configured. This will make it easier to apply our chosen fonts throughout the project. Since we're also adding a theme toggle to the dashboard, we'll include a custom Tailwind directive that allows us to manually switch between light and dark mode, rather than relying on the user's system preference. Now let's go ahead and add some layout styling to our app. This will help us structure the dashboard and set the foundation for the rest of the UI. After applying these basic utility classes, keep in mind that we'll be styling elements for both light and dark modes. Repeating the same classes for multiple elements isn't very efficient, so instead, we're going to create a custom Tailwind utility that includes the necessary colors for both light and dark themes. This way, we can simply reuse that utility wherever we need it, cleaner and way more maintainable. Alright, so in this custom utility class, we're combining several Tailwind classes that handle both background and text colors. Essentially, it sets the appropriate colors based on whether the app is in light or dark mode. We're going to create another custom class, which, as the name suggests, will be used for elements that appear in the foreground of our primary theme. This is ideal for anything that needs to stand out against the main background, like cards, containers, or highlighted sections. Let's go ahead and create one more custom utility class. This one will handle theming for elements that have borders. It'll make sure our border colors match the active theme, keeping everything visually consistent across light and dark modes. Alright, we can now start using these custom utility classes in our layout styling. It'll help keep our design consistent and make it easier to apply theme-aware styles throughout the app. Right now, using the theme might not show any visual difference, and that's because the app is currently in light mode. To switch things up, let's enable dark mode by adding the dark class to the HTML document. This will activate all our dark mode styles and show the difference in action. Now, to handle switching between the different modes, we're going to write a script in the head of our HTML. This script checks if the user has a saved theme preference in local storage. For future reference, we're going to store the theme preference in local storage when the switch button is clicked. If the stored theme is dark, or if no preference is saved but the user's system prefers dark mode, it adds the dark class to the HTML tag. That way, the appropriate theme is applied right when the page loads. Now, let's create a simple function that toggles the dark class on the HTML document. We'll then attach this function to a button, just for demonstration purposes, so we can manually switch between light and dark mode. Seems to be working just as intended. Now, let's move on to structuring the layout for our dashboard. We'll start by using this div as the main container, and then build out the different sections piece by piece. Let's start with the header. Let's create a directory inside the source folder for our components. Alright folks, at this point I'm not going to talk too much, since most of what we're doing now is just adding divs and applying Tailwind utility classes. I don't think you'd enjoy me calling out every single class or element as I go. It would get repetitive pretty quickly. I'll try my best to make the process as intuitive as possible, and I'll jump in with explanations whenever it's necessary. Trust me, after going through this project more than 1 million times while editing, you really start to know exactly where things need a bit more clarity. So if something calls for a deeper explanation, I've got you covered. Just so you know, I'll be keeping the browser window off to the side here so I can avoid constantly switching back and forth to view changes. That said, I won't be maximizing the browser too often to check the layout on larger screens. I'll save that for the key stages where it really matters. On the bright side, this actually encourages a mobile-first design approach, which is a good habit to get into anyway. So, with that in mind, let's continue. Let me take this relatively simple part of the video to say a big thank you to all of you for your support, both here on the channel and over on Patreon. I truly believe that every single one of you has played a role in the channel's growth. Whether you're liking the videos, sharing them, leaving comments, subscribing, or even just quietly watching in the background, you have my sincere gratitude. After implementing the theme toggle feature, you might notice something a bit off. When we switch to light mode, the theme goes right back to dark mode after a page reload. That's because we've hard-coded the dark class on the HTML element. So no matter what theme the user picks, since we're not storing the user's preference in local storage, the page will always load in dark mode by default. To fix this issue, we only need to store the user's theme preference in local storage. Alright, let's move on to building the main layout for our dashboard. I've loaded a future version of the completed dashboard off to the side so I can quickly reference whatever section or component we're currently working on. This should help keep things clear and on track as we build it out step by step. Right, so let's talk about the forecast section. On larger screens, you'll see the forecast displayed on the left side of the split layout. But when we switch to mobile devices, that forecast moves to the second split instead. To handle this layout change, we're actually going to create two instances of the forecast component, one specifically for large screens and one for mobile. However, we won't render both at the same time. Instead, we'll use CSS classes to control visibility based on the device size. Here's the important part. We'll pass a custom class name prop to each forecast instance to selectively show or hide them depending on the screen size. We can't apply this logic directly inside the component's internal styling, because that would affect both instances. Keeping the conditional styling external gives us more precise control and keeps each version of the component isolated to its target screen size. With that done, let's move on to the header. As you can see, on large screens, the header appears on the right side of the split layout, but on mobile devices it shifts to sit above both split sections. To handle this layout difference, we'll take the same approach we used for the forecast section. We'll create two instances of the header component, one optimized for large screens and one for mobile. Again, we'll only render one at a time, based on the device's screen size. Just like before, we'll pass a unique class name to each header instance to control visibility using responsive CSS. This ensures each version of the header is positioned exactly where it needs to be, without affecting the other. Alright, now let's move on to creating the layout for the second split. I want to make sure you have a clear understanding of how it's structured, so there's no confusion moving forward. Just a quick heads up, the layout behaves a bit differently depending on the screen size. On large screens, some elements are positioned differently compared to smaller devices. I hope the visual representation helps make things easier to follow. Awesome, we've got the base layout done. Now it's time to bring in some real weather data for our dashboard. To handle that, we'll use a powerful feature in React called Context. It helps us manage and share data across components without having to pass props down manually at every level. Let's take a quick dive into how context works so we can use it effectively in our project. In React, when you need to share data like user info or theme settings between components, you often pass it down as props. That's fine for a small app, but as your app grows, this can get messy. Let's look at an example. Here, we're passing the user object from app all the way down to profile through dashboard. This is called prop drilling, and it can become a nightmare when the data has to travel through multiple layers of components that don't even use it. React Context provides a way to share values across your component tree without manually passing props at every level. Let's rewrite the previous example using context. Step 1. Create the context. Step 2. Wrap your app with the context provider and pass the values necessary to the value attribute. Step 3. Use the context values within any component as long as that component is a child of the context provider. Now, the profile component gets the user data directly. No need to pass it through dashboard. So, using the same idea, let's go ahead and create a context provider specifically for our dashboard. To keep things clean and organized, I'm going to create a new directory called context. This is where we'll store all our context-related files. That way, as our app grows and we add more global data, everything stays neatly in one place. All right, now let's go ahead and create the actual context for the dashboard. Quick tip, make sure you get your imports right. I actually made the mistake of using the common JS import syntax instead of the ES6 syntax, and couldn't figure out why things weren't working until later. So save yourself the headache and double check. All right, now that we've created the context, let's take it one step further. We're going to hook it up to a custom hook, which at its core is just a simple function that returns useContext with our context. This isn't strictly necessary, but it makes things much cleaner and more elegant when we want to consume context values later on. Instead of importing both useContext and the context itself everywhere, we just call our custom hook simple and aesthetic. All right, now let's go ahead and set up our context provider. This is where we'll manage all the data for the dashboard. This will be a regular React component that we'll use to wrap the entire app. That means it needs to receive a children prop and then return those children, wrapped with our context provider, so the values we add can be shared across the app. Let's go ahead and define the state variables for the data we'll be fetching for the dashboard. These will hold things like the current weather, forecast, or anything else we want to make available throughout the app. Once we've defined all our state variables, we can return the children, wrapped inside our context provider. At this point, we'll pass all the state variables into the value prop of the provider so they're accessible throughout the app. Before we start using this context in the app, let's quickly set up a loading screen. This will be shown while we're fetching the weather data, just to give users some visual feedback that something's happening in the background. The reason we're not seeing the loading screen right now is because I have the loading state set to false. The interface is super minimal, just a black screen with a spinning div in the center. If you want to preview it, just set the loading state to true and you'll see it in action. With that done, let's go ahead and wrap our application's root component with the context provider. This ensures that all the data managed by our context is available throughout the entire app. It seems like the context provider was not exported, so let's go ahead and export it. Alright, here's where I discovered the wrong imports for the React context library, so let's quickly fix that. Now that everything's set up, let's go ahead and try accessing the values from the context in the dashboard. We can use our custom hook to pull in the weather data and display it wherever we need it. As you can see, we're able to retrieve and log the weather data inside the app component, all without passing it down through props. This is one of the major benefits of using context. We can access data directly, no matter how deep our component tree goes. And just like we did with the weather data, we can easily access any other data we added to the value attribute of the provider. Now that we have the basics in place, let's go ahead and define the structure of the weather data. Now that we have the structure in place, which also doubles as a fallback or placeholder in case the API fetch fails, we can go ahead and replace the hard-coded values with the actual weather data. This way, when the API call is successful, we'll dynamically display real-time data instead of the placeholder values. Here, we're going to display the current weather based on the user's preferred unit. However, You'll notice that I'm using some properties that weren't part of the initial weather data structure. Don't worry about it, since this is just placeholder data, it's perfectly fine. When we make the actual API call, we'll make sure to include these properties in the real weather data. Okay, now it's time to integrate our dashboard with a Weather API. We'll be using Weather API for this. It's a great service that provides all the weather data we need for our dashboard. First, head over to their website and sign up for an account. Once you're done, grab your API key. Back in our project codebase, we're going to create a local environment variable to store our API key, instead of assigning it to a variable. This helps keep it secure and ensures it's not exposed on the client side. It's a simple but important step for protecting sensitive information. We'll create this variable in the root of our project. When using env files in a Vita application, there's one important thing to keep in mind. Environment variable names need to be prefixed with Vita followed by an underscore in order for the variable to be accessible within the app. Now that we've set up our environment variable, we can go ahead and import it into our app and use it to make requests to the Weather API. We'll also set up a default city to fall back on in case the user denies location access or if their browser doesn't support geolocation. We'll also introduce another variable to help us control how far back or forward we want to fetch hourly weather data. In this case, we'll use it to get weather information from the past 6 hours, as well as a forecast for the next 6 hours. You can totally customize this to any number of hours under 24, depending on what works best for your case. But for now, I'm sticking with 6 in each direction. Let's go ahead and define the function that will handle making the request to the Weather API. Now, If you're wondering what the query parameter in our function is, that's going to represent the user's location. We'll use it to fetch weather data for wherever the user is. So when we call our fetch function, we should pass in either the user's city name or their geographic coordinates. To make that work, let's go ahead and use the browser's built-in geolocation API to get the user's location, and then pass that info into our fetch function. All right, now that our geolocation function is set up, let's go ahead and call it and see what happens. You'll notice the browser prompts us to allow access to our location. If we grant permission, the app will use that location to fetch real-time weather data. But if access is denied or unavailable, the app will simply fall back to the default city we defined earlier, so we'll still get weather info either way. If you check your console, you'll see the results from our fetch coming through. But notice that we're getting 2 responses instead of 1. That's a sign the fetch is being called twice. As you might remember from the previous video, this happens because the useEffect hook can run twice during development, especially in React's strict mode. So let's go ahead and fix that to make sure a request only fires once as expected. With a simple but effective use of the useRef hook, we can make sure our fetch only runs once. By using a ref to track whether the fetch has already happened, we can exit early on any additional executions. This prevents unnecessary fetch requests and keeps our app running efficiently. All right, now let's move on to updating our weather state variable with the data we get from the fetch results. We'll extract just the pieces we need, like temperature, condition, forecasts, and store them in state so we can easily use them in our UI. Our current weather data is showing up just as expected. Now let's proceed to retrieving the forecast data. For the forecast, we're specifically interested in the weather for the next day. The API's fetch response gives us forecast data for both today and tomorrow, with each day containing weather info for every hour, so that's 24 hourly data points per day. Rather than using all 24 hours though, we're going to simplify things by selecting data at 3-hour intervals. This gives us a clear snapshot of the weather throughout the day without overloading the dashboard with too much detail. Here's what's going on under the hood. We're accessing the next day's forecast using array notation, specifically the second item in the forecast array, which contains weather data for every hour of that day. Next, we're filtering those 24 hourly entries to only keep the ones that fall at 3-hour intervals. That's done using a simple condition that checks if the hour is divisible by 3. This gives us a nice spread of weather data throughout the day without overwhelming the user. Finally, we're mapping over that filtered array and pulling out just the pieces of data we care about, like the time, temperature in both Celsius and Fahrenheit, condition, and the conditions icon to use in our dashboard. Alright, let's jump into our forecast component and update it to display the forecast data we just prepared. Everything is looking good so far, and as you can see, the forecast is now displaying data in 3-hour intervals just as expected. Before we move on to displaying the hourly weather data, let's take care of something small Let's hide that pesky horizontal scroll bar that's showing up. Just like we did with the forecast data, we're now going to focus on the current day's data from the forecast day array. Once again, instead of grabbing all 24 hourly entries, we'll apply a simple filtering logic to get only the hours that fall within the past 6 hours from the current time. Using this filtering logic, we'll pull out the hourly data for just the past 6 hours from the current time. Once we've got that filtered array, we'll simply map through it and extract only the pieces of information we need. Alright guys, so we're aiming to display weather data from the past 6 hours, but you might be wondering why you're only seeing 2 entries show up. Well, the reason's pretty straightforward. It was 3 AM at the time I recorded this part, which means there just aren't 6 previous hours available yet. The only valid past hours in the data are 12 AM and 1 AM. So as the day progresses, you'll start seeing more hourly data fill in. Alright, now let's move on and put together our next data set. This one's all about the upcoming weather trend. Similar to what we did a while ago with the data set for the past 6 hours, this time we're looking at weather trends for the next 6 hours. Again, we'll filter all 24-hour data points in the array and return only those hours greater than the current hour, but also less or equal to 6 hours from the current time. So essentially, this simple filter logic will return all forecast data points between now and the next 6 hours. Once we've got that slice of data, we'll map through it and pull out just the bits we need, like temperature, time, and weather conditions. Alright, now let's take that data and actually put it to use on our dashboard. We'll use it to plot a graph here to show the upcoming weather trend. But before we get to the chart, let's start by giving the user some helpful recommendations based on the forecast. So, let's dive in and build out that recommendation feature first. The positioning of our recommendation component actually changes depending on the breakpoint. The current position of this component is part of the layout designed for larger screens. That's why the content of the component is not shown now, but is shown on a larger screen. So, if we want the same content to show up on mobile devices too, we'll need to make sure the component is included in the correct spot for the mobile layout as well. Alright, so inside this component, we're going to set up some simple logic using a bunch of if-else statements. The goal here is to figure out what kind of recommendation makes the most sense based on the current weather data. So, depending on things like temperature, chance of rain, or wind speed, we'll decide what advice to give the user, whether it's grabbing an umbrella, dressing warm, or just enjoying the sunshine. Alright, our function is all set. Now let's go ahead and call it and plug in the values. Before we move on, let's quickly take care of this overlapping issue in the layout so everything looks nice and clean. Alright, moving on, let's create the analytics component and start making sense and get some further insights from the weather data as well as several of the dataset we put together. In this component, we'll be crunching some numbers based on the weather data we've collected. We'll calculate the temperature change to determine whether the trend is rising or falling, compute the UV index, and generate a few other useful metrics. This will help give users a deeper insight into current and upcoming weather conditions. What this function does is to return the temperature trend based on the hourly weather data. It does that by calculating the difference between the earliest and latest hourly temperature readings, taking the selected unit into account, of course. Based on that difference, it determines whether the trend is rising, falling, or stable. It also returns the actual value of the change, shown as an absolute value, so it's always positive, regardless of direction. Let's move on to the next function. We'll be doing something similar, but this time using a different data set to predict the upcoming weather trend. Just like before, we'll determine whether the trend is rising, falling, or stable. In this final function, we'll calculate the comfort level based on the temperature and humidity values. With all that in place, let's go ahead and call each of these functions and use the return values to build out the component. Right. That was interesting. And with that, we've officially wrapped up the analytics component. I'd say it's looking pretty solid, and the desktop layout is coming together nicely too. We're almost at the finish line for the dashboard. Just one thing left. The chart. Unfortunately, I have to end the video here. That's because I used ChatGPT for this section. I don't really know how to go about it. Psych. Let's get into it. Alright, for the charts, we're going to use Recharts, which is a charting library, of course, built with React components. I don't think any explanation or history of Recharts would be necessary. It just works. So let's go ahead and install it in our project. We'll be making a few tweaks later on, but for now, let's keep it simple and display a chart using the weather trend dataset, which holds hourly weather data for the next 6 hours. Now, if you remember, when we were structuring the return data for the weather trend, we added an extra temp property and initially set its value to 0. But what we're going to do now is update that value based on the actual temperature, taking the selected unit into account. And we'll see exactly why that matters in just a moment. Just for reference, here's the temp property I was talking about earlier. Alright, let's go ahead and import the necessary components to draw our chart. Be sure to grab the correct imports for each individual component. Now, take a look at how these components receive their data, which each relying on properties from the data to plot the chart correctly. This is exactly why we added that extra temp property earlier. On top of that, we hooked the temp property with the actual temperature based on the user's preferred unit. That means we don't need to conditionally render a separate line component for Celsius versus Fahrenheit. We just feed in one consistent property and it works no matter the unit. Simple and clean. We'll just make a few quick style tweaks to the tooltip and that'll wrap up this component. Alright, that just about sums everything up. But wait, there's one last thing. On larger screens, we've got one more chart to display. This time, it's a graph showing weather data from the past 6 hours. Using our hourly weather dataset, it's a great way to give users more context on how the weather's been trending before now, kind of like setting the stage for what's coming next. We're going to reuse the same graph component, but this time we won't be using the weather trend dataset. Instead, we'll pass in the appropriate data as props. This way, the component stays flexible and reusable, and we avoid duplicating code. Now, since we're displaying a different chart, we'll want to show a separate title to help users tell them apart. To do that, we'll pass in another prop to differentiate between the two uses of the component. Then, inside the graph component, we can simply use that prop to display the appropriate title above the chart. Alright folks, that brings us to the end of this video. If you made it this far, don't forget to leave a like, share it with someone who might find it useful, or drop a comment below. Any kind of engagement really helps support and grow the channel. Thanks for watching, and I'll see you sometime in the future.